So this is our direct burial fiber optic cable. It's designed to be planted directly into the ground, building a pure point-to-point 10 gigabit link. Hi tech lovers, welcome back to Fast Cabling. So today we're not just talking about faster internet, we're talking about building the backbone for the future of food. So this is a regional smart farm, and they're facing a problem that's becoming more common than you think. They have all this incredible technology, AI-driven climate sensors, a network of 4K cameras, but the network holding it all together is about to collapse under the weight of its own success. Their data has outgrown their wires, and if we don't fix it, the farm can't scale. And right now, two of their main buildings are connected by our Cat 6 copper Ethernet cable. They're about 400 feet apart. Now, in a perfect world, that cable can handle a gigabit per second. But here's the twist. Their expansion plans call for new data hub up to 1,000 feet apart, and that's nearly 3 times the 328-foot limit for reliable copper. So problem 1 we're facing, distance. And problem 2, bandwidth. They're not just sending emails, they're streaming dozens of 4K cameras to feeds for security and crop monitoring. They're running real-time AI interference on soil conditions to optimize water usage. So this data isn't just big, it needs to move now. And low latency is critical. Their current network is a bottleneck, and the terrain is rugged, uneven soil and tractor path, so pulling conduits everywhere would be a nightmare. So we needed to rip out the old playbook and start over. The obvious answer was fiber optic cable, but we needed a connection that could handle 10 gigabit per second, not just for today, but for the future. Because once you start adding more sensors, more AI, that 10G capacity gives you the headroom to grow without ever touching the ground again. And fiber isn't just about speed. Single mode fiber, the kind we're using, can easily handle 10G for 10 kilometers. That's over 30,000 feet. And that's completely immune to the electrical interference from all the heavy machinery on the farm. And most importantly, it won't act as a lightning rod during a storm. So it's the perfect solution. But installing it traditionally would mean trenching and burying expensive conduits for the entire 1,000 feet run, which kills our budget. So this is our direct burial fiber optic cable. It looks tough because it is. It's designed to be planted directly into the ground. No conduits required, surviving soil, moisture, and pressure all on its own. At its heart is the fragile glass that carries light, but wrapped around that is a suit of superhero protection. First, there's a layer of water-blocking gel. If the outer jacket gets nagged, this gel swells and seals the inside, stopping moisture from fogging the glass and killing your signal. Then, there's the armor. This is the muzzle. Stop rodents from chewing through it and protect the glass from the crushing weights of the soil and even a tractor driving over it. And the final layer is the tough black HDPE jacket. Its resistance to UV light and abrasion. And this cable is self-sufficient. And we chose this for 2 simple reasons. First, it's incredibly cost-effective. We're saving a fortune on PVC conduits and the labor to install it. Second, it's resilient. These armored, gel-filled beads will last at the frost of winter and the heavy equipment of summer. And now for the fun part, the setup. We're building a pure point-to-point 10 gigabit link, and in each building we have a 10G capable switch. So let's begin. Now at this building we have this beast, the 24 gigabit plus 4 10G SFP plus managed high PoE switch. Now this switch has 24 PoE port and also for 10G SFP plus slots. First, I'm going to use this short patch cord to connect our switch to a network video recorder so we can display video footage. Then I'm plugging in another Ethernet cable to connect to a WebSmart PoE switch. Remember, this farm has multiple equipments, so we need as many switches as we can. And I'm connecting it to a bullet camera. By using PoE technology, we're sending both power and data to this bullet camera. Now this is done, let's get back to our switch. Now these are the SFP slots, and we need this magic device, SFP Plus module. Now think of an SFP Plus port as a universal translator for your network. You can put in a module for short-range fiber or long-range fiber. And here we're using this 10G base LR module, which are designed for the long haul over single-mode fiber. Now a cool trick we're using, BiDi, bidirectional transceiver. That means we can send and receive data on a single string of fiber, which doubles the efficiency of our network. Now speaking of which, this is our pre-made fiber optic cable. It comes from the factory with these rugged connectors already attached. This is a huge deal because it means no field splicing, no trying to fuse glass together in a dusty trench. It's plug and play. Now it has two strings. Let's use string C. Simple, plug it into the SFP transceiver. And now let's follow our fiber optic cable to another building. Now at this building, we have another 8-port 10G SFP high PoE switch. Again, we need our SFP transceiver. Let's plug it into the SFP slots and get our fiber optic cable. Now because we are smart, so ran a cable with 2 fiber strings. We only need one for this link, which leaves us a dark fiber spare for future upgrades or a backup link. Remember, we used string C. So let's plug it into the SFP transceiver. Now we have our connection, and for this switch I'm going to go ahead and plug in 2 Ethernet cable. One is for another bullet camera, and one is for our Wi-Fi access point. So basically our connection is almost done. But here are the best practices we follow to make sure this link survives for the next decade. First, avoid tight bands for your fiber. Because fiber doesn't like to be kinked, we make sure every band was at least 30 times the cable's diameter, nice and gentle. And we should bury the cable at least 24 inches deep because that puts it below the frost line and well out of the way of any casual digging. And here's a crucial step. Even with direct burial cable, we should use a short section of PVC conduits at a critical point, like the building's entry point, to protect the cable from rubbing against the concrete foundation. And finally, before we cover it all up, we documented everything. We won't be guessing where the cable is. So now let's look at our big screen monitor to check out our live video feed. Here we go. So it's not just a connection, it's a seamless pipeline. Those 4K cameras now stream without a hitch, and the AI servers can analyze data from the field in a real time. So we turned a physical limitation into an infinity resource. By choosing the right tool for the job and installing it with care, this smart farm is now ready for whatever the future throws at it. Thank you very much for watching. If you're planning a long-distance network project and have questions about direct burial fiber or 10G setup, feel free to drop a comment below. We read them. And don't forget to subscribe for more deep dives into the tech that builds the world around us. And I'll see you in our next video.